Hello guys, welcome to another video, and in this video I'm going to explain a very interesting problem which is unequal arrays. So let's get started. Here is the problem statement and it says that you are given two arrays A and B each of length n. You can perform the following operation on array A 0 or more times. Okay, so the operation is select any two indices I and j in the range from 1 to n where I is not equal to j, and you can increase the value of ai by 2 and decrease the value of aj by 2. Okay, and your task is to find the minimum number of operations required to make array A and B equal. Okay, now one note is given here. It says that two arrays are said to be equal if the frequency of each element is equal in both of them. Okay, so what does this mean? Let me explain you. If we have two arrays and the array contains element, the first array contains 1, 2 and 10 and the second array contains 10, 1 and 2, then both these arrays are equal because the frequency of each element is equal in both the arrays. Okay, now one more thing is array may contain duplicate elements. Okay, so let me explain the problem with this example. The example says that we have two arrays of size 3. The first array is array A, in which we can perform the operation, and the second array is array B, and our task is to make the array A equal to array B. Okay, how we can perform, like in this array A we can perform the operation. So let me write this array A 2, 5, 6. Now I'm going to choose two indices. The first is J and the second is I. Okay, I can increase the value of ai by 2 and decrease the value of aj by 2. So now the array will become 3 and here I will have 8. Okay, so I have performed the operation one time. After that I can again perform the operation and like I will decrease this value by 2 and increase this value by 2, then it will become 2. This element is now 1 and this element is now 10. Okay, now you can see that this particular array is given to the array B, which is given to us, is equal to the array B. Okay, now how many times we have performed the operation? So we have performed the operation two times now, so 2 is going to be the output here. Okay, now I hope you guys have understood the problem well, so let's talk about the solution now. Okay, so I'm going to take the same example in order to explain the observations. The first the first array that we have is 2, 5, 6, and the second array that we have is 1, 2 and 10. So this is array A and this is array B, and n is equal to 3. Okay, now uh, let's talk about the operation that we need to perform. So the operation is we can choose two indices I and j, and I can increase the value of ai by 2. So I can increase the value by 2 and I can decrease the value of a of j by 2. It will become minus 2. Okay, now I want you to think of one thing here, that if I increase the value of this index by 2 and I decrease the value of this index by 2, so ultimately I'm adding value 0 to the whole array, right? Let me explain this. If I have two elements in the array, which is the first is 4 and the second is 2, then I can increase the value of this element by 2 and decrease the value of this element by 2. But before that, let me write the sum of these two elements, which is 6. Okay, now when I do plus 2 and minus 2 for these two elements, then they will become, this element will become 6 now and this element will become 0 now. Okay, now you can see that the sum is again 6. So one observation is, doesn't matter how many times I perform the operation, sum is going to remain unchanged. Sum will be unchanged unchanged even after performing the operation. So even after performing the operation, right? Okay, so can we utilize this observation? Yes, of course we can utilize it. How we can utilize this? Let me explain you. So now I want you to think of one thing again, that ultimately when I keep performing the operation, then this array A will become equal to array B, and if these two arrays are equal, in that case one thing is sure, that the sum of A will be equal to sum of B, like sum of all the elements in array A will be equal to sum of all the elements in array B. Why? Because the arrays are equal. Okay, so and one more thing is, the sum of array A is unchanged, like doesn't matter how many times I have performed the operation, but sum is going to remain same ultimately. Okay, so this means that the initial sum of this array A should be equal to the sum of this array B in order to make them equal. So the condition is, in order to make both the arrays equal, the sum should remain same, right? So I can write one thing, that if sum of A is not equal to sum of B, in that case, is it possible to convert the array A to B? No, it is not possible. So I will simply return -1. So this is the first equation that we have. Let me call it equation 1. Okay. Now let's talk about the second observation. In order to explain the second observation, I am going to take a single array A, which is having elements 2, 5 and 6. Okay, our task is simple, that let's take this element 5. We can either increase the value of this 5 by 2 or decrease the value of 5 by 2. It depends on the way I perform the operation. So let's say I'm increasing the value by 2. So if I do 5 plus 2, then it will become 7. Again, if I do 5 plus 7 plus 2, then it will become 9. After that 11, after that 13, and so on. And if I do minus 2, then it will become 3. After that it will become 1, after that it will become -1, and so on. Okay, so you can observe one thing from this. You can observe that 5 is only become an odd element after adding the value 2 or subtracting the value 2, and same is the case for 7, 9. Like if you see this, then I'm getting a series of odd elements, right? So I can write one thing, that and it's quite simple, right? If I do odd plus 2, then I will get an odd element itself. You can see from this series. Okay, after that if I do odd minus 2, then I will get odd number itself. Okay, same is the case for even number. Like if I have an even number 2, and if I keep adding 2 in this, so it will give me 4, 6, 8, 10, right? It will give me a table of 2. If you notice here, then it is giving me all the multiples of 2, right? So I can write one more thing, that even plus 2 will be even always, and same is the case for even minus 2. Even minus 2 will be even. Okay, now can we use this property? Yes, of course we can utilize it. If we have an array, let's say we have an array A, and which is having elements, again I'm taking the same example, 2, 5, 6, and we have array B, and this array now contains element 1, 2 and 9. You can see that we have two odd elements here. So in order to make a array A equal to B, I need two odd elements in the array A again, because I can only make odd elements equal to odd elements. There is no way that I can make these even elements equal to even elements, right? So how many odd elements are there? I have two odd elements. How many odd elements are there? I have one odd element here. Okay, so I can either make this 5 equal to 1 or make this 5 equal to 9. Let's say I make this 5 equal to 9. So which element I will make equal to 1 from this array? There is no any such element, right? So in that case, there it is not possible, and I will simply return -1. Let me write this observation as well. The observation is quite simple. It says that in order to make both the arrays equal, we need equal number of odd elements and even elements. So, but I will check a condition, that if count of odd elements in A is not equal to count of odd elements in B, in that case, I will return -1. You can ask me that, hey, why you are not checking the even elements? So let me explain you. One thing that we know for sure is the length of both these arrays are equal, right? So let's say the length is n. Okay, and we have the count of odd elements is equal for both. So let's say the count of odd element is x. So if the count of odd element is x, then the count of even element will be equal to the remaining element that we have. So the count of even element will be n minus x, and if the count of odd element is equal, then the count of even element will automatically be equal in both the arrays, right? So that's why I'm not checking count of even elements. You can, or you can check one more condition, like either you can check this condition or you can check the count of even, like count of even in A is not equal to count of even in B, right? In that case you can written -1, so you can check any of these conditions. Okay, till now we have figured out two observations. So now I'm going to call this equation 2. So let me use a black pen here, so I'm going to call it equation 2. So we have two equations, right? The first equation is checking the sum and the second is checking the count of even and odd elements. Now let me talk about a final observation, which is the third observation. So let me take an example. We have an array A which contains elements 6 and 2. Okay, and I have an array B which contains element 0 and 8. Okay, and our task is simple, that we need to make these two arrays equal, right? So how we can make them equal? I can either convert this 6 to 0. Okay, so I can convert this 6 to 0 and this 2 to 8. Okay, how I can perform? I will perform the operation like I will always choose this index as j index, because I need to decrease this value, and I will choose this as I index. I need to increase this value. So I will do ai equals to ai plus 2. So when I do so, then this will become 4, and if I subtract 2 from this, then it will become 4 again. Okay, after that, this is the first time I perform the operation. I can again perform the operation second time, then it will decrease by 2. Okay, it will increase by 2, it will become 6, and this will decrease by 2, it will become 2. Okay, I can again perform the operation, and by doing this I can decrease this value to 0 and I can increase this value to 8. So now this will become 0 and this will become 8. Okay, so we are done. Our task is done here. You can see that in three operations, we have converted this array A to this array B. Okay, so is 3 is going to be our answer? No, 3 is not our answer. Why? Because we can convert, we can do the same task in minimum number of operations, like in lesser operation. And this is what I have to do. Like the problem says that your task is to return the minimum number of operation required. Okay, so what are the minimum number of operations? It's quite simple. What is optimal in order to convert this array to this array? I will convert this 2 to this 0. Why? Because 0 is more close to this 2 than this 8, right? If I convert this 2 to this 8, then I need to increase the value like by 6 times, right? And if I convert this 2 to 0, then I can simply do -2. Okay, this makes sense. So how can I bring like closer elements together? This is the question. So in order to make the closer elements together, I can simply sort these arrays. So if I sort this array and this array, then it will become 2 6 and this will become 0 8, right? Now you can see that we have closer elements together, and this is what that I want. Okay, so this is about the even elements that we have, but it also may be possible that we have a list of odd elements, right? Okay, so if we have a list of odd elements, in that case I can do something like if I have odd elements 3 and 5 and I need to convert them to 1 and 7. So now you can see that these two lists are already sorted, like 1 is closer to 3 and 7 is close to 5. So I can simply perform the operation, like I can decrease this value by 2 and increase this value by 2, and in one operation I will be able to perform make these two arrays equal, right? This is what I have to do. So can I write the pseudocode for this? Let me write the pseudocode. The pseudocode is simple, that I need an even list. Even list. This is going to store all the even elements in A, and I need an even list, one more even list. This is even list B, and this is going to store all the even elements in B. After that, I need an odd list, which is odd list A, and this is going to store all the odd elements in list A. After that, I need an odd list B, and this is going to store all the odd elements in list B. But why I am separating all the even and odd elements from the list A and B? This is the question. The answer is simple. If you notice the third observation, like if you notice the second observation that we have made here, so you will find that we can only convert an odd element to an odd element, right? And in even element to an even element. And this is what I'm doing here. Like if you notice here, then I can only make these two elements equal if it is even. But if I sort the whole list, then it may possible that I will have elements like 2 1, after that 3 2, after that I will have 5, and I will have here, okay, so let's say 5. So you can see here that these are closer element, but one is even and the second is odd. So can I make these element equal? No, of course I cannot make them equal. Doesn't matter how many times I do minus 2 or plus 2. Okay, this makes sense. So that's why I'm separating even and odd list here. Okay, now I can sort all this list. So sort all list, all. Okay, so let me write it again. I will write sort all list. Why I need to sort? Because I want all the closer element together. Okay, so once I have the closer element together, like I have something like 2 0 and 6 8. So now you can see that closer element are together. So now I can simply traverse the whole list, and I can check how many times I need to decrease or increase the value. Let me tell you how I can do this. I can like for all elements in even list, even list of A and even list of B, right? Even list of B. I'm traversing both lists simultaneously. So you can see that this is the even list that we have. Okay, so what I can do, I can simply, how many times I need to decrease this value, this is the question. So if you do 2 minus 0, then you will find that I need to decrease this value 2 times, right? But I have the like chance to do minus 2 in one go. So I don't need to do something like 2 minus 1 and then minus 1. So I can simply do minus 2 in one go. This means that I can do minus 2 one time in order to make these two elements to equal. So how I can mathematically write this? I can simply write if absolute difference between these two values, like uh, even list of A of I minus even list of B of I, right? By 2. Dividing by 2 simply means that how many times I need to do minus 2 minus 2 minus 2 or plus 2 plus 2 plus 2, because I can decrease by 2 in one go. So that's why I am dividing by 2 here. So this is how many times my answer is going to increase. Okay, so answer is a variable which is going to store the minimum number of operation, which is initially 0. Okay, now I need to do the same operation. This is for the even list, right? So I need to do the same operation for the odd list. So I can simply do the same operation for the odd list here. Okay, and after that, when whole operations are completed, then my answer is going to give me the solution, right? No. Why? This is the question. Why answer is not giving me the solution? So let's look at this. If I take the same example, like where I have 2 6 and 0 8. So you can see that if I do for this 2 minus 0 by 2, then it will say 1. What does this one means? This one simply means that if I do simply for this 2, if I do minus 2, then it will simply become 0. This means that one time I can do minus 2 in order to make these two elements equal. Okay, this is this one tells me. Okay, after that, for this again 6 like 8 minus 6 by 2 is going to give me 1. So I will have 1 here. Okay, and finally I will have the answer as 2. But answer is not 2. Why answer is not 2? Because I can choose two indices at one time, and after that I can do plus 2 and minus 2 in one go. Like this whole is one operation, and I'm counting this as two separate operations. So how to like resolve this thing? I can simply do finally answer minus like answer by 2. Why? Because I have counted each operation two times. Why? Because I'm counting minus 2 and plus 2 as two different operations. So this is how we can solve this problem. Let me show you the code. Okay, so on the left hand side I have the Java code, and on the right hand side I have the Python code and the C++ code. Okay, so in the Java code, I'm making four lists which are is going to store odd numbers and even numbers in list A and B. Okay. After that, I'm calculating the sum here. I'm storing the even and odd numbers from list A and B. Okay. After that, this is the first observation that we have, right? If you have noted this down. that sum should be equal in order to make both the arrays equal. Okay, and the second thing is the count of odd elements should be equal in order to make both the arrays equal. And I want you to see this thing here, that how I'm calculating the count of odd numbers. Since I have already stored the odd numbers, so we can just find the count of the list which is storing the odd numbers. Okay, after that I'm sorting all the list. This is what I'm doing here. On the even on the right hand side, you can see that I'm sorting all the list, and this code is also going to same as I have written here. Okay, after that finally I'm doing the same operation that I have explained you on the whiteboard. Okay, and finally I'm returning answer by 2. So this is the code of Java and C++. Let me show you the Python code as well. So here I have written the Python code. Here I'm using Python list in order to store all the values. After that, this is how I'm initializing the sum. And now this is very interesting concept in Python, like how I can zip, how I can traverse two lists in one go using the concept of zip. Okay, and now you can see that here I am storing the values, even and odd values. After that I am checking the same condition here, and finally the sorting and calculating the answer. Okay, now I hope the approach is clear to you. So this is all about this problem. If you like the video, then you can hit the like button, and you can subscribe the channel if you are new here. Thank you.